Okay, so how the studies and the preparation for the exams, everything going on?
Going good, uncle.
Okay, okay. So last week we have looked into some calculus, right?
Yes, yes.
The differentiation thing, and at the end I mentioned that whenever we do differentiation with whatever the proper understanding and why we are doing that, keep an eye on the final result, so that when we do integration, actually when we have the results of the differentiation, actually we are looking for the original problem. Do you get that?
Okay, yeah.
So that is really important. Otherwise integration slowly become a kind of very difficult task. Okay,
Okay.
so let me recap the differentiation. So when we have a function like f of x, you can see the whiteboard, right?
Yes, yes. Yes, uncle.
When it is a function, if it is defined, then we have to understand what is this. This is actually the x is our independent variable, right? So independent variable, and it can vary on its own. So like time is a good example. So when we know that a quantity like a time independent variable is changing, we are asking the question with respect to the change happened with the independent variable, this dependent function or the variable, dependent function or variable, how this is varying. Okay,
Okay.
so that's the thing we are questioning. So we are trying to understand, and in doing so, when the data is all given and we make a function and plot and everything, when it is a data like points, okay, data means data points, then we use the difference actually. So the difference like delta f by delta x. So the delta x is our change in x, and with respect to that, what is the change in the function itself? Okay, change in the function f. Okay,
Function.
so when it is a difference, then normally we simply do it like the delta f could be, delta x could be 2 points here, second point take away the first point, and correspondingly we need to calculate the f of x1. Let's call that as a f1, and f of x2, we can say that that value could be f2. So we look into the delta f as f2 minus f1. Okay,
Okay.
so that will actually give us the delta f by delta x will look like f2 minus f1 divided by x2 minus x1. Okay, so these things are for data points. So when we look into the equivalent in the a, a continuous variable, so the data points is not that definitely the variable itself has to be a discrete or finite one. Maybe because of the measurement, like we may be measuring like after 1 second, after 2 second, after 3 second, even the time continuous variable may look like a data. Do you get that?
Okay.
Okay, so we need to understand that. Okay, so eventually when you measure something, we may need to fit a function to make it look as a continuous function, and we may need to do the same thing, but in that case when you make it as a function, continuous function, and it has a continuity and a differentiable, then we make it as the definition as a differentiation of f with respect to the x variable, that is actually defined as the limit our delta x, the one we understood in the discrete form, going to 0, the change happened in the x for the function, the x plus delta x value minus f of x. You're okay with that?
Yes, uncle.
So simply we are saying that when the data points are like, we can make it as an analytical function. That means we can substitute the x value into the function and calculate the f value for any value in the x, and if it is continuous, then we define it like that. So, and we saw some example also last week, and we did that. And I mean, we can see more example also, but we need to understand, okay, let's say if I differentiate a f, which is a function of x with respect to the independent variable x, then we need to really find the df by dx. We call that as a f prime. Okay, so that is actually a f prime. And also still, I mean, we need to continue differentiating the x itself with respect to the x. We call this part as the chain rule. Okay, I will give you an example that could be understood. And the f prime is actually defined as our df by dx. Okay. So what I mean here, take an example. Let's take the f of x is defined as a 3x plus 3, for example. Okay. So this may look very simple, right? If I want to differentiate the f of x with respect to the x, it may look straight away that, okay, so in the place of f of x, substitute or replace the defined function to us. Then can you tell me the answer for this? When you differentiate 3x plus 3 with respect to x, the answer will be?
Yes, uncle. 1 minute. 3x, it will be 3.
Yeah, 3. So basically, we, as it is a addition or subtraction in the operand, in the differentiation, we can actually distribute the differentiation individually. That is 3x and d by dx of 3. Okay.
Yes, uncle.
When we look at the x, what is the variation happening with the 3x? This says it is thrice. Also, we could do one more step, like the 3 can be taken, so the 3 is independent of the x, that can be taken out as a scaling factor outside, so it will look like 3 dx by dx. Okay.
Yes.
Plus this 3, from the x point of view, 3 is a constant, it is not at all changing. So when the x is changing, we are asking what will be the change happening with the 3. No change at all, that is our 0. Okay. So this eventually, the dx by dx is the 1, the answer will be simply a 3. So with experience, by the look of it, straight away we can say this 3x plus 3 differentiation will be a 3.
Yes.
But in this case, actually I want to add that extra part as the chain rule. I take a bit of a room here. What I meant is, when we did d by dx of 3x plus 3, and when we distributed that like 3, and we have a dx by dx, that is actually we are doing that. Do you see that? Even though this is the differentiation of the f, we still do the differentiation of x also. Do you get that?
Yes, sir.
Yeah, so as long as there is a x, then we do that. So this will become like a d by dx of 3. So this is what I
Yes,
was
sir.
trying to say. So this part become the chain rule. You're okay with that, right? So let me go bit here. Take the same example. Okay, I write it in the top. The example is the f of x is 3x plus 3, right? we can write this as a, can you factorize this? 3x plus 3 can be factorized as?
Factorize, not differential.
Yeah, if you
3 into x plus 1.
3 times x plus 1. So factorization is simply, this is actually in the form of addition. Do you see that?
Yeah.
Can we convert that into a multiplication factors? Yeah, this is possible because there is a common factor 3. So it will be 3 times x plus 1. So now if in this form, let's say if you are differentiating the df of x by dx, still okay. So this will be d by dx of, use the 3 multiplied by x plus 1 as such. Now as again, only this factor is dependent on the x, so the 3 can be taken outside as a common factor. Do you see that? So that will be
Yes,
3,
uncle.
then d by dx of x plus 1. So now we need to do the chain rule completely. It will be done like 3 and d by dx of operating on the x plus d by dx of 1. You see that?
Yes,
So
uncle.
this will eventually, this will go to 1 and this will go to 0, right? So because of that, the answer will be simply 3. Either way, we will get the same answer. The 3 is the same answer here and here, but the understanding will help us. You're okay with that, right? What we are doing.
Yes, uncle.
Okay, so now see how the chain rule will help us. Let's say take another example. F of x is actually 3x squared plus 2x, for example. Okay, this can be straight away differentiated like df by dx. It may look very easy for us. So substitute the d by dx, and for the f is 3x squared plus 2x. Then this is an addition. The d by dx can be distributed for the individual term. In the first term is 3x squared. The 3 is constant, nothing to do with the x. That can be taken outside the differentiation. X squared differentiation will be, do you know what is, do you remember the x squared differentiation?
Yes, uncle. 1 second. So it will be
Yeah, you have to do it by hand. I mean, so you are not that fluent with straight away
no
telling that.
x.
No, x squared differentiation will be
Oh,
2x.
yeah, 2x. So it will be 6x totally.
Yeah, 6x. Okay, that is
Okay.
the 6x, and then add
6x
with
plus 2.
6x plus 2. Okay,
Okay.
this is fine. But if you see, this f of x can be, this is a 3x squared plus 2x. Can you factorize this?
Yes, uncle. 1 second.
Look at the two terms. Tell me what is the common factor between
X.
them.
So it's x. So x into 3x plus 2.
3x plus 2. Develop the confidence by looking, because this is not a big complicated too many steps involved, right? You are actually
Yes.
having a 3 squared added with the 2x just to feel it. Okay, there is a x is the only common factor between them that can be taken as the first common factor multiplied with when the x is taken in the 3x squared, the rest will be 3x. The idea is when you multiply the x back into the 3x, you should get the 3x squared. That is how we factorize. Okay.
Yes, uncle.
Okay with that. So also in the second term, 2x is there. X is factorized. Then 2 is written as a plus 2. Then if you check it, like if the x is multiplied with the plus 2, that will be plus 2x. So we have correctly done it. Okay. So in this form also we can differentiate the f. So that will be d by dx of, so we can say that it is a x multiplied with 3x plus 2. We are still okay to differentiate this function. Only thing is the two factors, both of them are dependent on the x. Okay, so if you look from the x point of view, differentiating variable point of view, both of them are dependent on the x. So now we need to use actually we call them as a product rule. Simply we ask the first factor to wait until we get the job done on the differentiation of the second factor. Keep continuing our job of differentiation. Ask the second factor to wait outside and keep doing the differentiation of the first factor. You're okay with that?
Yes, uncle.
Okay. This is what we do in any case, but this is a must. We cannot forget that. So I take a bit of a room here. Even in the previous example, if you had f of x equals 3x plus 3, in this case also df by dx will be d by dx of 3x plus 3, right? Then we
Yes,
can
uncle.
write this as a d by dx of acting on the 3x and add with d by dx of 3. So in this case, this thing will go to 0. Here also we can consider that as a multiplication. This is still fine. So what we can ask the 3 to wait outside, differentiate the x, one of the factors of the 3x, and ask the x to wait outside and differentiate the 3 with respect to x. Do you see what we are doing?
Yes, uncle.
This also can be treated as a product rule, but what will happen as the 3 is a constant, this will go to 0. So because of that, the answer will be simply a 3.
Yes, uncle.
We are okay with that. So that is the same
Yes.
thing we have. So when we see two factors like x multiplied with 3x plus 2, we just ask the first factor to wait outside and differentiate the second factor. Add with the second factor has to wait outside, differentiate the first. So in doing so, we can see that this will be x dot, this differentiation will be simply a 3 plus the 3x plus 2, the differentiation of dx by dx is a 1. You're okay with that?
Yes, uncle.
So this will look like a, so this will be a 3x plus 3x plus 2.
3x. Yeah.
Yeah, so that will be 6x plus 2. So we will
Yes.
arrive at the same answer, like 3x plus 2. In always mean whichever way we do, we will come back to the same answer. But in doing it in different ways, we know that in different forms of the given function, we still know how to differentiate them. Okay?
Yes, uncle.
Okay with that?
Yes.
So let's take a different function. So the chain rule will get much better. Let's say we take the sine of our 3x squared plus 5x plus 4 by root x, for example. Okay, this is just a function. It's just a trigonometric function acting on, and the argument for the trigonometric function is a polynomial function. Do you see that?
Yes, uncle.
And there is a radical. That is what it is. That's it. No need to panic or anything. So we want df by dx. That is what we are trying to do. Straightforward. Like we know the f definition, just to use the definition of the x here, that will be sine of 3x squared plus 5x plus 5 by root x. Right?
Yes, uncle.
Okay. So do you know the differentiation of the, because we are differentiating the sign of a particular argument and we are differentiating with respect to x. The sign argument is a function of x, so definitely the sign will get differentiated. The sign differentiation is what? Do you remember the sign differentiation? If I give you like the f of theta is actually sine theta, then our d f of theta by d theta will be the cos theta.
Cos theta. Yes, yes, yes. And for cos theta will be minus sin theta. Yes.
Yeah, basically, if you look at into the geometrical form, this will look like a. Let me draw a one cycle of the sine wave. Okay. Okay, so this is with respect to x, our sine x. Okay. You see, I mean, we are actually looking for the slope. You see, the slope is the tangent is very steep here. Do you see that?
Yes, uncle.
And slowly when you move along the x, the slope become flat and it become zero slope here. And the slope get reverse. Do you see that?
Yes, uncle.
And it goes to the maximum steep here, going to negative to the positive. My pen is not writing. And then we get the slope on the, you see the negative slope, and go to 0 again, and go to positive slope again, and you go to the high steep again. Do you see that? So if you draw that with respect to x, it will, okay, so this will be, we are just drawing the slope. That's it. The slope points are drawn here. That is what the understanding is. So so if you find the d by dx of our sin x, so this will look like we have a very high slope and go to the 0. Do you see that?
Yes,
Hello?
uncle. Yes, uncle.
You're okay with that?
Yes,
And go
yes.
to the negative slope and go to the negative peak and again go back to 0 and come back to the maximum slope point here. That is what the differentiation is doing for us. Do you see that?
Yes,
So
uncle.
this look like our cos x. So if you do the same thing for our, if the f of theta is given as a cosine theta, then we know that the answer is df by d theta is actually minus sine theta. Why it is? If you draw the same thing, if you draw the cosine curve is actually, this curve is the cosine curve. Do you see that? It is having a slope which is actually 0 here. No slope at all. Okay.
Yes, uncle.
And then the slope is going to a negative slope. Do you see that?
Yes, uncle.
Negative increasing slope, and it goes to the maximum here, and then it started going into a reducing positive slope here. Okay, that is what the negative slope here, and then it goes to a flat 0. So this will look like from 0 it will go to the like this. You get that? The same thing. So
Yes,
we
uncle.
differentiated the cos x with respect to x, then this will look like a minus sin x curve. You're okay with that? Okay.
Yes, uncle.
Hello?
Yes,
Yeah,
uncle.
can
Yes,
you?
uncle.
Yeah. Okay, so we know that sign differentiation, the argument inside the sign is actually the a function of x. That means we need to first write the differentiation of the sign as a cosine 3x squared, whatever the argument that should appear as such. That is the first job need to be done. Okay. So yeah. Okay.
Yes.
We have done this, and also should have made a mistake here. Okay, it should be a 4.
Yes, uncle.
You have to look at and correct me also if I make mistake. Okay.
Yes, uncle.
Okay, so we have done the sine function has been differentiated, but the sine is a function of acting on a polynomial. So we need to continue the differentiation of the argument. Do you see that?
Okay, yes.
Plus 5x minus, no.
It can be written as 4 by x to the power minus 1.
Yeah, you can do that. Not minus 1, minus
No, sorry,
half.
minus 2.
Square root,
Sorry,
yeah. So that will be 4x power
minus.
minus half. Okay.
Yes.
So that will help us to deal with this. So this will be equal to cosine 3x squared plus 5x plus 4 by root x. And this differentiation will look like
It will
the
be
first one.
6x.
Sorry, 6x.
6x plus 5.
Hmm.
1 second. And plus
No plus.
1 second.
You have a plus 4x power minus half. So the
Minus
4 is
half. So it will be minus 2
minus 2
x
x
power
power
minus 3 by 2.
X power minus 3 by 2. Right? You're okay with that?
Yes. Yes, uncle.
X power minus 3 by 2. Okay. So this minus 3 by 2, that radical can be written as cosine 3x squared plus 5x plus 4 by root x whole thing multiplied by 6x plus 5 minus 2 by the 3 with the
Yeah.
minus 3 and half comes to the denominator will become x power plus 3 and half. It is
Plus
a
3.
3 and half. 3 and half is 1 and a half. So 1 of
Yes.
that x can be taken factorized and the remaining will be a root x. You're okay with that?
Yes. Yes, uncle.
Okay. So you see, we have done it. So better to be written as the polynomial has to be written in the front. Okay. So 6x plus 5 minus 2 by x root x whole thing multiplied by cosine 3x
Sin
squared
3x squared plus 5x plus 4 by root.
4 by root x. Okay. So you have a pen and pencil, right? Pen and paper, right?
Yes, uncle.
Yeah. Can you write this complete answer? So can you
Yes,
write
yes.
the answer? This
1 minute.
copy it without mistake. Copy the first function also.
Yes.
The f of x is write down this first and then write down the final result.
Yeah.
So that let's see. Have you written it carefully? Carefully check it. Okay, I made. Okay, I written everything. Okay, yeah,
Yes, 1 second.
yeah.
Yes, uncle, I will do it now.
Just write the answer only. The steps. This thing is getting recorded. You can watch it later if you cannot get that answer. I'm saying.
Yes,
Write the
uncle, noted.
yeah. Done.
Yes, uncle.
Okay. I erase everything. Let me see another one option. Oh, okay. Because in this app I could not make more pages. It's actually I need to erase everything. So now tell me, let's say we are given with a function called y equals cosine. Can you tell me the final answer? That was 3x squared, right? No. Let me write the polynomial first. Okay. What I meant is the polynomial was 6x, right?
Yes, uncle.
6x plus 5
Plus 5 minus 2 by x
uh,
root x.
x whole thing multiplied with the cosine of, now this will be
3x
3x squared plus
plus
5x,
5x plus 4 by root x.
yeah, plus 4 by root x. Okay, let's say we are given a function like that. We may ask to find what is integral of y dx. Okay.
Okay.
So actually we started with a function, a sine function, and we differentiated and we got this answer 6x plus 5 minus 2 by x root 2 whole thing multiplied by cosine of that argument. But now there could be a new problem, like they might have given this a polynomial multiplied with the cosine of an argument, and that cosine argument is also looks like a polynomial. Do you see that?
Yes,
Okay.
uncle.
So we have the the y. So this integral symbol and y dx. So this x is the variable with which we are integrating. Okay. So we need to know how this y is dependent on that x. Then only we can do the integration. So write this as integral. We need to substitute the y here. That will be 6x plus 5 given to us as a minus 2 by x root x.
X.
Okay. Cosine of 3x squared plus 5x
5x
plus
plus
4
4 by root x.
by x. This whole thing has to be integrated with respect to x. You get that?
Yes, uncle.
So when we are having a job like an integration of a function like that, we call a method called substitution. Okay. What this is going to do is, like you see, the cosine function is having a polynomial argument. You see that?
Yes.
Okay. We need to just use a new function. Let's say theta. Let it be the function of x, such a way that we write that as the 3x squared plus 5x plus 4 by root x. Do you see that?
Yes, uncle.
This will actually help us. The cosine of this whole argument can be replaced by cos theta. Do you see that?
Yes, uncle.
Okay. But original problem was completely in terms of the variable x. Now we are introducing a new dependent variable theta, which is dependent on the x. Then we need to know how this theta function is varying with respect to x. Simply we are asking the question, what will be the differentiation of this theta with respect to our x itself? You see that?
Yes, uncle.
We need to know, because we introduced this function to make our life easy. So this whole cosine will become a cos theta. But we are actually integrating with respect to x. So we need to not only replace the argument of the cosine into a simple theta, the whole integration has to be changed to the integration with respect to theta. Everywhere the x comes, because of the definition we have given for our theta, the whole problem of the integration should be converted to the theta. Do you get that?
Yes, uncle.
For that, we need to know what is the meaning of this in terms of theta, and also we need to know the meaning of this also with respect to theta. So we know that the dx is the change happening in the x. So we are asking the question, what is the change happening in the theta with respect to x? This will help us to do that job. Okay. So this will be d by dx of whatever the function we just defined as the theta. Substitute it here, 5x plus 4 by root x. You're okay with that?
Yes, uncle.
So this differentiation will become 6x plus 5. We have
5.
just done previous. So it will look like minus 2 by x root x. You're okay with that?
Root x. Yes. Yes, uncle.
Okay. So this is what our d theta by dx. So d theta by dx is this. Then we can say that d theta is actually the whole thing what we got on the other side, minus 2 over x root x multiplied by dx. Do you get that?
Yes, uncle.
So we have taken the dx to the other side of the equation. That's it. Okay. So now you see, because of that our life become much easier. So if you see, we made the cosine of 3x squared plus 5x plus 4 by root x to become a simple function like a cosine theta. Do you get that? Because we know that the theta is nothing but our polynomial. That is what we have taken for the substitution. Do you get that?
Yes, uncle.
So instead of this whole quantity, that is the main purpose. We introduce the whole polynomial to be our theta, to make our life easy. So the whole cosine of that polynomial can be written as a cosine theta. We just substituted the whole polynomial in terms of theta. Okay. You're okay with that?
Yes.
Also, we know that the remaining in the integration will be our, apart from the cosine theta, the remaining part, the 6x plus 5 minus 2 by x root x whole thing multiplied with dx. This is our d theta. Do you see that? That is what we have derived also. Do you see that?
Yes, uncle.
Okay, so this whole integration, will now look like, if you replace the two things, it will look like a integration cosine theta d theta. Are you with me?
Yes, uncle.
So this part is actually replaced with our cos theta, and the remaining, this whole product of this with the dx is replaced with the d theta, because that is how the theta was defined, and because of that d theta is like that. Okay, any question?
No question, uncle.
Okay, so now we have to integrate the cosine theta. So we need to use our basic understanding of the trigonometry differentiation. Let's say there is a function called f, which is actually a function of theta, which looks like a sine theta. Then the df by d theta will be our cosine theta. So the df is actually cosine theta d theta. So if you integrate on the both sides, add all the small pieces of df and add all the small pieces of this cosine theta multiplied with the d theta, that is what our f will be. So the f will be the sine theta. Do you get that?
Yes, uncle.
So this is the connection between, it is like addition and subtraction, equal and opposite mathematical operation. The differentiation is the proper version of the division, and integration is the proper version of the multiplication. Do you get that? The differentiation is the division. Do you see that? We are dividing.
Yes, uncle.
Change happened with the f with respect to the change happened in the theta. The integration is, we are just adding all the small pieces repeatedly. That means it will be a multiplication. Okay. So this integral cosine theta d theta will be a sine theta. You're okay with that?
Yes, uncle.
So eventually we have to replace the theta. So the sine theta will be actually equal to, so we write the original problem, that is integral y dx, that will be sine of, replace the theta back from our original substitution, 3x squared plus 5x plus 4 by root x. You're okay with that? And also whenever we do the integration, we need to add a integration constant c, because this might have lost during the differentiation. Okay, you are okay?
Yes, uncle.
You don't sound that comfortable. What is going on?
No, uncle, I'm fine. It's just that I found this a little bit hard, but then now I'm able to get it.
Tell me which part is not that.
No, first the cos and sine, I didn't get it at first, but now I understood it.
The very basic differentiation of the trigonometric function, you mean?
Yes, uncle. That's what I got confused in that first.
Okay, but do
Yeah,
you see
but then now
what I did here?
Yes, uncle. Now I'm able to follow now.
Yeah. So there are some basic, I mean, we can get it from the very fundamental limits also, but you need to know that, for example, there is a d by d theta of sine theta differentiation will go to a cosine theta. D by d theta of our cosine theta will go to a negative sine theta. Okay. So
Yes.
there are other basic things. So d by d theta of theta power n will be the n theta power n minus 1.
Yes.
So d by d theta of e power, let's say a theta, for example, then we have to, okay, I won't write the a theta straight away. Let me write only the theta. Okay, e power theta to begin with. So e power theta, this is actually e power theta itself. Okay.
Okay.
So these are all very, very basic fundamental thing. With that, we can actually get any other differentiation. For example, let me start with, first thing could be, this is very fundamental list. Okay. Fundamental list of derivatives. Okay. List of derivatives. One important thing what we need to look, you see the differentiation are all with respect to theta, and the operand which that is operating on also containing theta. If, for example, what I mean is, let's say if somebody asks you to solve for d by dx of sine theta, what is the answer?
Cos theta. Sorry, cos x. No.
We are asking the differentiation with respect to x. When you look from the x point of view, this is.
So it doesn't.
Do you see that? Either you can say that
should be the same variable.
It has to be, but that is not the problem given to you. Why you expect the problem has to be in the way you want? This is the given problem. If you consider that the theta has nothing to do with the x, then the answer will be 0. Do you see that? Because theta is something totally nothing to do with the x. This is one way to do it. The other best way is, this is the right understanding. If you are differentiating with respect to x on a sine theta, we have to say that the sine theta will become a cosine theta. As a chain rule, we are differentiating with respect to x, there should be a d theta by dx. Do you get that?
Okay, yes, uncle.
So this is what is taking care of everything. Let's say if the theta is nothing to do with the x, actually this is the one going to 0. Do you get that?
Yes, uncle.
Okay, that is when we can say that it is equal to 0. Okay. So this is the right way to write it. So if they say that theta is totally independent of x, automatically this will go to 0. That will make this complete differentiation is a 0.
Yes, uncle.
Are you okay with that?
Yes, uncle.
So like that, let me put an example. Can we find d by dx of e power theta x? Okay.
Yes, uncle.
So we know that when the differentiating variable and the e power of whatever that argument, the power argument, if exactly the same, then we know that answer is exponential of that, like this. Do you see that?
Yes, uncle.
That is d by d theta of e power theta will be e power theta. But in this case example, we are differentiating with respect to x, fine, but the argument which has to be differentiated is exponential of theta x. As long as there is a x in the argument, that means this is a function of our differentiating variable. Do you get that?
Yes, uncle. So
now straight away we need to say that exponential differentiation will be an exponential. That is the first job. Okay. Keep continuing the differentiation, because the argument has to be, as a chain rule, we are supposed to differentiate that with respect to the x, the argument itself. Do you get that?
Yes, uncle.
So now we can say that there are two ways to continue this, e power theta x. Let's say the theta could also be a function of x or may not be. So what will happen? Open the bracket. So this will become, keep the theta outside and differentiate the x with respect to x. Add with, keep the x outside, differentiate the theta with respect to x. Are you okay with that?
Yes, uncle.
So I just completely did this differentiation of theta multiplied by x as a product rule. Do you see that?
Yes, uncle. Yeah.
So this will become e power theta x, and this will be theta plus x d theta by dx. It stays like that. If we have been told that theta has nothing to do with our x, let's say theta is not at all a function of x, then this will go to 0.
Yes, uncle.
Then only this will. So if d theta by dx is equal to 0, this is actually the correct definition for this. Means if d theta by dx is equal to 0, that means theta is not dependent on x. Do you see that? Okay with that?
Yes, uncle.
So when we say some function is not at all dependent on a particular variable, then we have to write mathematically as d of that function by dx, that will be equal to 0. Okay. So in that case, we can say that d by dx of e power theta x will be simply our e power theta x multiplied by theta plus x d theta by dx. We know that we have been told that theta is nothing to do with our x, so this will simplify to e power theta x multiplied by theta plus x multiplied by 0. So this will be simply theta e power theta x. You're okay with that?
Yes, uncle.
Very fine.
Yes, uncle.
Okay. Because it's all about the understanding. So if we have a function like, let's say, okay, let me ask you, what is d by d theta of e power theta x? You're taking time. Hello? Hello?
Uncle, can you hear me now?
Yeah. Okay. So you
Uncle, the last time actually I wanted to tell that because I wanted to copy that down, but then I think you couldn't hear me that time.
the whole calculation.
Yeah.
Yeah, but okay, I mean, the
I
whole
will see that
calculation.
in the recording. I will see that in the recording,
Yeah,
uncle.
yeah, yeah, yeah. That's why I said, I mean, we can continue. If you had doubt, we can discuss about that. But the idea, I mean, you have to develop
Yes,
that
uncle.
one.
This one also, I really am not sure how to do this.
This differentiation.
Yes, I didn't get it.
Okay, I mean, it's okay. Let's get a white page here. Let's say if we are asking, okay, what is d f of theta by d theta? What is the meaning of this? First, try to understand that. This is one. We are asking to if the theta variable is changing. Okay. And
Okay.
with respect to that variable, we are asking what will happen to the a variable or a function which is dependent on that theta itself. Do you get that?
Okay.
So what we are trying to see here is, yeah, okay. So whatever it is, because the f of theta is not completely defined. It could be any function. For example, the f of theta could be a straight line. It could be a 3 theta plus 5. Right? This is a straight line. Do you understand that?
Yes.
Because this looks like y equal to mx plus c. Do you see
Yes.
that?
Yes.
So the y equal to mx plus c is actually y is a function of x. Mx plus c.
Mm.
So the c is the x is the independent variable, and in the way the y is dependent on the x is x raised to the power of 1 is the same thing. The f is a function of theta, and how the function is defined is theta power 1. Do you get that?
Yes, uncle.
This could be, I mean, this could be totally a different function. Our f of theta could be easily our e power 5 theta. You see, this is a different example. So this is how our function f is dependent on the theta is e power 5 theta. That means if the theta takes a value 1, then the f value become e power 5 multiplied by 1. Do you see that?
Oh, okay. Yes. Yes, uncle.
So we need to first have the grip about the function. The function is a very simple thing. Yeah, like okay, take our own life. Time moves. Like after a year, what will happen to us? We will age by one more year. Do you see that?
Yes, uncle.
So one of the property, our age will be a function of time. So we will say that, okay, I cannot say that I cannot age at all. I will age with time. So age is a variable which will be dependent on the time. Do you get that?
Yes, uncle.
Like that. Let's say put our growth, okay, from our age beginning when we are baby, with our age, our height and weight will grow. So the height and
Yes.
weight will be a property of our the time.
Yes.
Will be a function of a time. So that will increase around when we complete the teenage and everything, it will saturate, and after that most likely our height and weight. So when we draw the graph, so with respect to the years as a function and the age, this will be straight line, right? I mean, maybe the year may be, okay, I was born in 1972. So then that will be from that year onwards, it will be a straight line. Do you get that?
Yes.
Because if you take a year 19, I mean what, now it is a 2022, simple, find the difference between the, so here we are saying if you find the difference between the two, so this will be 2022 minus 1972, this is a 50.
Yes.
Okay, so that means if you go here and you meet here, that will be the whatever the difference happened here, that is our delta y, that is our years. Okay, that is our 2022 minus 1972 will be a 50. Then our delta a, which is our change in the age, will also our 50 minus 0 will be 50. Do you get that?
Yes.
So this will definitely, we can say that age is a function of our year, and it will be a straight line which will be exactly y itself. Do you see that?
Yes, uncle.
But if you say take another example, let's say if you draw a graph between this may be like this. So this may be our height versus our years. Okay,
Okay.
somewhere here we may saturate, right?
Yeah.
Maybe around say that 18 years or something like that, we may saturate. So now the height h function, still it is a function of y. I am writing the y as the years as a variable. Do you understand that? But now
Yes,
it is not a
yes.
straight line. You see that this is growing and then it is getting saturated. So we need to find a function to define that.
Okay.
Okay, so that may look like for example our height is measured in terms of centimeter, and let's say it is my height is 170, I think 176 centimeter or something. Okay, so if that is the case, so we started from, I mean, some very small value, we reached that. So the height with respect to the year could be like 172, 176, 1 minus e power our minus y or something like that. Okay, whatever the minus y. Do you see that? And there may
Okay.
be a coefficient in front of that. It could be a because at what rate it is growing. Do you see that? And after that it is saturating.
Okay.
So this is what is, we call that as the mathematical modeling. Mathematical modeling. That is what we are studying all around the mass, different kind of thing. Because if I put the okay, this has to be in the other way. Yeah, it has to be. This is not right. It has to be one. Yeah, I put it in the wrong way. So okay, this we don't need this. It is okay to be like this. Okay, do you see that? Let me erase
Yeah,
this.
okay.
What I'm saying. Let me explain even why I put that function. So I say 176 e power minus, no, yeah, plus. Okay, okay, you see why I am keep correcting this. I will tell you why I am doing that. This will be 1 plus e power minus alpha, something like that. Okay, it could be 1 power alpha
Okay.
alpha or a, our the number of years. Okay, what I try to say here is when you put the y equal to 0, that is when we are just born. Okay,
Okay.
okay, so that will be this whole thing will become a 1
Yeah.
because e power 0.
Yes.
Because, so this has to be okay. We need yeah, it is not exactly modeling, but what we are saying, if you substitute the y value here, like it has to show you whatever the height at that year. Do you see that?
Yes, uncle.
And after that we saturate. So we need a good model here, but I'm just trying to see here as 1 plus, yeah, this 176 should be in front of the, yeah, it has to be. So there has to be some another quantity here. It could be some fixed quantity. So what I want to say here is, let's take the 176 next to the, so the e power like a function will help us to model that. Okay, so if you see a wave, if you see something like a water wave or sound wave or something like that, that will propagate like this with respect to time. Do you
Okay.
see that?
Yes, uncle.
Then we need a function like an amplitude multiplied by our sine of that, whatever the wave, with the frequency of the wave will look like this. So now the property, the a will be fixed by whatever the peak amplitude. The a value is this, and it is oscillating between capital A plus capital A to minus capital A, and the frequency is fixed by the omega, meaning one cycle is completed in a time period of capital T. Okay, then the frequency is actually 1 over T. This will say per second how many number of waves are there, and also it completes one cycle in every t seconds. So that means it is covering 2 pi radians
Okay,
in
uncle.
2 seconds. You're okay with that?
Yes, uncle.
So we call that as the, we can, when we know that the angle swept in a time of t period, then the rate of rotation is actually given by the angle of rotation in a one cycle divided by time taken per cycle. You're okay with that?
Okay. Yes, uncle.
So this will be actually 1 over t is a f, so this can be written as a 2 pi f also.
Okay.
So then this becomes the function. So we can say that if you call the amplitude as a y, then we can say y is a function of time, that is actually a sine of omega t.
Yes,
When
uncle.
you substitute the t equal to 0, sine of 0 will be a 0, so the amplitude
Yeah.
is 0. That's the meaning. When you substitute the t is actually equal to, at here the t is actually equal to t by 4. You see the quarter cycle. Do you see that?
Yes, uncle.
So we can substitute that. That is actually equal to a. Should not substitute in there. I should. So we are asking what will be the y value when t is actually equal to t by 4. Then the function value should be, use that value of the t in that omega multiplied by t by 4. You're okay with that?
Yes, uncle.
So that will be a sine omega. Already we know that it is a 2 pi by capital T multiplied by t by 4. That will become, this whole thing will become a t cancel, and the 2 pi by 4 will become a pi by 2. You see that?
Yes, uncle.
So that is 90. Sine 90 is 1. So that will be
1.
equal
Yeah.
to the a itself. That is where the peak amplitude is.
Yeah.
The a. And if you substitute the t is actually equal to of t, capital T, then the sine, that will be actually sine pi. Sine pi will be 0. So the amplitude becomes a 0.
Yeah.
Then when you substitute 3 pi by 2, it will go to the negative. So sine 3 pi by 2 will be minus 1.
Yeah.
Okay, like this. Like for everything happening, the dynamics or some property of like our height, weight kind of thing, even the human population in the world or the virus growth or something like that, all of them can be modeled in a particular way mathematically. Okay. Then once you will
Yes,
do
uncle.
that, we call that as a function dependent on, particularly mostly on the time. Then we want to analyze at what rate it is growing or in what rate it is going to get populated. All those things can be studied using the calculus. That is what we are doing.
Okay, uncle.
Okay. So when we have that is what I said, the very first list of d by dx of x power n is actually n x raised to the power of n minus 1. And d by dx of e power x is actually e power x itself. D by dx of sin x is actually cos x, and d by dx of cosine x is actually minus sin x. That's it. So once we know all these things, then you need to know chain rule, product rule, and a quotient rule. Actually, the product rule and the quotient rule are related, so we need to know three properties.
Okay, uncle.
And that's it. Differentiation, once you know the basic these things and the very basics of the differentiation itself and these three rules, then you can do any kind of differentiation with any function.
Okay,
Okay.
uncle.
So we will look into more examples next week, but
Okay.
go through the video today, whatever we discussed.
Yes, uncle.
And then we will look into more deeper, so that you will get more comfortable with this calculus also, like you do the addition or subtraction. Okay, don't worry about that, we will get there.
Okay,
But
uncle.
you please look into the video again. Okay.
Okay, uncle.
Okay, then we will see next week. Okay.
Thank you, uncle.
Okay, take care. Bye.
Okay.